Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hey, everyone. Thanks for joining us for the next session of our RAG Hack, Add Multi-Channel Communications in Your RAG App. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is recorded. It'll be available to view on demand on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter. Milan, thank you so much for joining us today.
Hello, everyone. Good morning, good evening, and good afternoon. My name is Milan, and I'm a product manager at Azure Communication Services. And today we are going to talk about adding multi-channel communications to your RAG app. So the agenda would be that I'm going to talk about logical layers of a RAG app. Then I'm going to segue into what is Azure Communication Channels. And then we'll cover two demos. One would be adding WhatsApp channel to a RAG application. I'll do a code walkthrough, and then I'll showcase a demo where a customer will be talking to a RAG app using their phone. So we'll be using PSTN channel for that communication, and then again, a code walkthrough. So I know a lot of you who have joined may already know what RAG is and may have been following the hackathon streams, but we'll do a quick refresher for those who might be joining this session for the first time. So RAG is retrieval augmented generation. And as Pamela said before, it is the concept of retrieving data from a custom knowledge base that your LLMs can then use to answer based on that specific data. For example, if the user asked a question, how fast is the pre-SV? Then there's a search that happens within that custom knowledge base to figure out this answer. And that knowledge is transferred to the large language model, which uses this specific information and then convert it into a response that is more human-like and answers the query to the user. The pre-SV has an acceleration of 9.5 seconds. So this is an example of what RAG is in very simple terms. Now, if we were building a RAG app, what are the logical layers that we'll consider? So the first three here are related to the data part of it: the source, ingest, and store. Source is basically where your data resides. Is it on a SharePoint site? Is it on a website? Is it a bunch of PDF files? Is it a database system? Ingesting is about taking that data and passing it to the store. How do you ingest this data? And store is, of course, where do you store it? How do you index it? How do you vectorize it? How do you basically massage and store this data so that it is retrieved by your application in the most effective manner? Now you see that the last two layers, processing and serve, is something that I have highlighted. That's because I'm going to talk about these two layers during my session, because my session is about adding communication layers on top of your RAG application. So that happens in the processing and the serve layer. So serve, as the name indicates, it's about the last layer where you are, serving all the goodness that you've created in your application to the user or to the customer who's going to use your app. So it's about the, interaction layer, whether your customer or user is talking to your app through chat or whether they are interacting with your app through a phone. So that's the serve layer. Processing is the layer where the business logic resides. Processing layer gets the input from the data layer, from the RAG concept, but it also gets input from the external sources. It also gets input from the user. What is user typing in the chat? What is user saying as a voice command? So the processing layer takes the input from the knowledge base, it takes the input from the external sources, and then generates a meaningful response based on this information. So double clicking into these layers, what do they mean when we talk about communication channels? Well, serve, like I said, apart from chat, there are other messaging channels that folks can use like SMS or email. And then when it comes to audio, there's obviously VoIP and there's PSTN. PSTN is the telephony channel. And then I've added WhatsApp here as well, because why not include social channels as well, like WhatsApp and WeChat, because a lot of our users and customers use social channels. So that could be another channel through which people interact with, AI applications. What does it look like for the processing layer? Now, when you add these channels into your applications, it is very important to consider how are they exposing these inputs for your application to ingest. For example, let's take VoIP or PSTN line where an audio input is coming in. Does your channel expose that input as live audio stream so that your LLMs can get real-time data as to what the user is speaking, and it can generate responses faster? Or is it giving you transcriptions where you have to wait for the full sentence before the LLM can process it? And similarly for SMS and chat, the conversation history needs to be given from the communication channel to your application. So what is there that is available in the Microsoft ecosystem when we talk about communication channels? Like I said, I work for Azure Communication Services. So today I'm going to talk a bit about Microsoft's intelligent CPaaS, which is Communication Platform as a Service, and it is called Azure Communication Services. So folks in the chat, if you could drop a message and let me know that how many of you have heard about Azure Communication Services, have used ACS, or are hearing about it for the first time. Just drop a message that would let me understand the familiarity level of this audience about this platform. You can just type, heard about it, used it, hearing for the first time. So I'd love to see your comments in the chat. So ACS is basically, by the way, ACS is not our official acronym, but for brevity, I'm going to use ACS in my presentation today. So ACS is our communication platform, which is built on the same infrastructure that powers Microsoft Teams. What that means is that the rich communication capabilities that you see in Microsoft Teams, like chat, audio, video calling, we took those capabilities, we white labeled them, and made them available as APIs for developers to use and add these capabilities into their applications so that they don't have to worry about the underlying infrastructure. We take care of that. They just have to call our APIs and get these capabilities added into their applications. So these are the core services that we have available today: voice and video calling, chat, telephony, SMS, email, and WhatsApp. And we support 4 major languages: C#, Java, JavaScript, Python. Today, the demos that I'll show will be in C#, but you can very well, take those concepts and use other languages that are listed here to build your application if you prefer one language over the other. Now, when building RAG applications, I do want to encourage you to think beyond chat. I know most of us, I would say, have already, have interacted with some sort of chat app, be it Copilots or be it chat GPT. And chat apps I see a lot of chat apps being built in the marketplace. But in this hackathon, I do want to encourage you, and I do want to offer you some solutions where you can explore additional channels, which are listed here. I do want to call out that email, if you want to use email as a channel for your RAG app, ACS will not be a good choice right now because we just have one-way email support. We don't have support for inbound email. But other than that, all the other channels have two-way conversational support. All right, so now it is showtime. I'm going to show you my first demo. And for that, I need to connect my phone. because I want to project my WhatsApp to the screen, and then we'll do a conversation on WhatsApp with a RAG app that I've built. So I'm starting broadcasting from my phone, and let me pull out that app. Okay, this is here. And now I need to go to my application, which is deployed. Let me minimize this. Bear with me for a second. Okay, here it is. So I have my phone here and I've opened WhatsApp here, which is getting projected on the screen. On the left is my demo application, which I've deployed on Azure. So the left is just like a website to show you the conversation history. Sometimes the projection of my phone doesn't work, so I rely on this to show you the conversation that's happening. So the scenario is that there is a company called Contoso Electronics, and they sell calculators. And they wanted to build a self-service application or a bot which can help their customers resolve any issues that they are having with their calculator. So let's say I am their customer and my calculator has stopped working. So I open this WhatsApp chat with Contoso Electronics and I will type hello. So on the left, you can see that the responses are coming in, but you can also see it on the right. So how can I assist you with your calculator today? If you're encountering an error, could you please let me know the error code? Give me a sec. I'm checking. Of course, take your time. It's 1002. Okay, so here you see, I got the response, which tells me how to fix it and what the error is. So that was a quick demo, and I will stop the broadcast and go back to my slide deck. So I've linked the code repo, which we are going to browse just in a minute. But let me talk about the scenarios that this kind of application is useful in. So you just saw the customer support scenario where, businesses can build applications where they can create these self-serve options where the bot is connected to the knowledge base, which is basically the troubleshooting guidelines, and then they can help resolve customer queries, at least the 100 ones. And then other scenario could be order inquiries. Imagine a retail shop, maybe Milan clothing shop, and customers could use WhatsApp or SMS to get their order statuses instead of calling someone or instead of talking to a human. An AI bot can very well do that because the bot can be connected to their ordering system and then use RAG to get information about the order details that the customer is asking about. Similarly, booking and shopping assistance is another scenario. Imagine a travel company where a bot can help find the flights the customer is looking for. For example, I can ask the bot that, hey, I want to travel from Seattle to Dallas on 26 September during the first half of the day. Can you find out the flights that are available? So the bot can do that very well as well. Appointment queries is another option as well. Like instead of calling the front desk to reschedule your appointments, you can talk to a bot to help you find other appointments from your service provider. And in the center, intentionally, I've kept this user preferred channel as the core of all these scenarios. Like, why do we even need to think of multi-channel, multi-communication channels when it comes to providing services to your customers and users? The reason is that today there's so many different channels and customers and users have their own preferences. It could be based on their age, it could be based on their geography, or it could be just like personal preference. For example, I use WhatsApp a lot, and my friends in the US, they use iMessage a lot. And I know in Europe, WhatsApp is popular as well. But some people might prefer, logging onto the website and chatting with a chatbot there. So kind of there's an opportunity for businesses to figure out what is their users' preferred channels and then provide those channels to their customers to increase customer satisfaction. All right, let's now come to the code part. How do you build an application just like what I showed you 2 minutes ago. So we'll start with the architectural diagram, and then I am going to show you the code repo. I'm also looking at the comments to see if there's any question. Yeah, I think Pamela has already answered that, so thank you. So I'll move ahead with architectural diagram. So the user was using the WhatsApp client, and they were sending a WhatsApp message. It goes to the ACS messaging service, which then sends notification to our backend application, telling the application that, hey, a message has been received on your number. The application then takes that user input for... Okay, wait, let me go back. No. Okay, I'm back. So the application then takes the user input, and it takes the knowledge base. For this, I am just using like regular prompt to pass knowledge base, and then it passes to the LLM. I'm using Azure OpenAI service for that. And the LLM will give you a response, which will then be passed from your application to the ACS messaging service by calling an API, and then it will get rendered on the WhatsApp application. So if you had to do something like that, if you had to add WhatsApp channel to your application, what are the steps that you'll have to do? Well, I've listed 6. Actually, these are 6. These are not 5. So apologies for the typo. But there are 6 steps that you'll have to do, and I will show you that as well. And on the right in my slide deck, I've also pointed out 2 important functions that you'll need to focus on if you're going through my code repo. So let's get to business on the Azure portal. So the first step is creating communication services resource, which is an ACS resource. So everything starts from here. You'll come to the Azure portal and you will create an ACS resource. We won't create one because we'll save time, and we'll take a look at the resource that I have already created. Checking the font size real quick. Okay, so you have this resource created. Now on the left side, you have a bunch of different options: telephony, SMS, and then you will see advanced messaging. For WhatsApp, that's where we go. We'll go to channels, and this is where you register your WhatsApp business account with Azure. So I do have that registration already there, but if you were to start from scratch, you'll click on connect, and you'll start the connect process from the Azure portal itself. This does tell you all the 3 things that you require to complete this process. The first is the WhatsApp business account. Now, this is something that you can do in the workflow that I'm showing, but you could also create WhatsApp business account outside of Azure portal on the WhatsApp business account website. And then you will need a phone number to associate your business account. So when I was talking to Contoso Electronic, there was a phone number that was on the other side, which was receiving those messages, right? So either you can use your own number, which I did. I already had a spare number, so I used that. Or you can buy a number from ACS and use that number. So ACS pricing for number is as minimal as $1 per month or $2 per month, depending on the number that you're taking for the US. For the other countries, I've linked the pricing details in my slide deck as well. And the third one is that you need to have a business, but it's just on paper. You don't have to have an actual business, because I don't, but I still created this demo, and I'll show you how you can do that. So the second step is that you'll select a phone number. I do have ACS number, so let me select that. Let's move next. Now, you have to verify your phone number with WhatsApp. If you were using your own phone number, this step will be very easy, because you will have your phone and you can see the OTP or one-time password that you'll get on your phone. But if you're using an ACS number, you'll have to do one additional step, which is easy as well. And it's linked in my README for my code repo, where you'll have to set up an event grid viewer where you'll get this one-time password. So the next step is logging with Facebook. Because WhatsApp is owned by Meta, this is something that we do not control. This is a workflow that is controlled by Meta. So they need a Facebook account if you're using WhatsApp for business. So you just keep going to next. And I already have a profile created, but if you were doing it for the first time, you'll create a business portfolio, you'll put a name, you'll put some email. And this is the place where I was saying that there's a workaround where you don't need to have an actual business. You can actually link your Facebook page, which is marked as business, or a website that you have created as your blog post, or even an Instagram account that you would have created, which is marked as business. So there are hacks to go around this. And then you put all of these other things and press next. And that's how you connect your account. So let's go back and look at the channel that I've already created. So this is the channel that I have for my demo. And this is the interesting piece that you need to copy from the Azure portal after you're done with all of these steps, because channel ID is an important configuration that you'll need in your application. Okay, so now the first 3 steps are done. The next step is adding ACS messaging library, and then we're going to add WhatsApp messaging code, and then we are going to register an endpoint to receive the notification from ACS messaging service to tell your app that, hey, a message has been received. So let's go to the code repo for that. So this repo is built on MVC concept, but you can use minimal APIs as well. So you might not need all the classes that are here, because I needed that, the web UI that I showed where I wanted to see the conversation, but that's completely optional. If you want, you can create a minimal API, just create 2 endpoints and you're good to go. So the important class for you when you're looking through my code repo would be webhook controller. So as you can see here, there is a prompt. And let me increase the font size. This is a simple prompt that I used for my AI bot. And for this app, I kept the RAG part very simple because I did not use any other service provider. I just provided my knowledge base in the prompt itself. And you can see that there are some error codes, and there are like resolution and problem statements for these error codes. And that's where the AI bot was getting the information when I shared the error code with my bot. So this is a prompt. And you will have to expose an endpoint for receiving the event grid notifications. So this is important. Like I said, your app needs to know when a message is received by Azure Communication Services messaging services. So this is where you'll handle those events. And for being able to do that, you'll have to register your server's endpoint in the Azure event grid. And I'm going to show that to you in a bit, but let's assume that that's done. So in this function, you'll have something called handle grid events. And this is where you'll have the logic of what do you want to do when a customer sends you a message through WhatsApp. So you get the message, and then you add the message into the chat conversation history. Now, remember, whenever you are passing anything to LLMs along with your system prompt, you also have to pass the full conversation history for the LLMs to have context. And that's the reason I'm forming that list here as well. Now, there's a method called respond to customer async. In this method, I am calling Azure OpenAI LLM to generate a response. And after generating a response, here at line 144, that's where I call ACS services to send WhatsApp message. Now let's take a look at send WhatsApp message. It's just 3 lines of code. So that's the beauty of using something like ACS, because it does the underlying work. All you have to do is write minimal amount of code to use that communication channel. And as you can see, even the AI part is minimal here because it's a very simple app. I just call the complete chat async method, but you can use Azure OpenAI or any other LLM that you want to use for your application. Now coming back to the resource again, And event grid is very important for implementing anything with ACS. For most of the things, even like SMS or handling incoming calls, you'll come here in the event grid and you will add URLs for where you want these events to be delivered. So as you can see, I have two of these created. One was for my local server and one was for my deployed applications. So if you are doing something like this, you'll click on event subscription and you will select an event called advanced message received, and you will select endpoint as webhook and then configure an endpoint. Now, if you're running your application locally, you can expose your local server through dev tunnels and ngrok. If you've not done that before, don't worry. It's the description or the steps are there in my README. So here's where you add that URL and then you add webhook. And if it's deployed on a server like I did, I'll add the server URL and add webhook and create an event grid. So that's all you have to do. I know the WhatsApp business account creation step seemed like a lots of step, but that's like one thing that you do in the beginning, and after that, you don't have to do it. And for setting the WhatsApp messaging, to and fro communication channel, these are the steps that you'll do. You'll create an ACS resource. You'll connect your channel with your WhatsApp business account. You'll write two functions, main functions, which is sending WhatsApp message and handling grid events. And then you will expose your local server or deployed service to event grid as a webhook. And that's when you'll get the messages. So that's the summary of all the steps that you need to do for adding WhatsApp channel. So I'll pause here and see if there's something in the chat that I need to answer. And Pamela, if you think something is there, feel free to call it out as well.
Well, the main question is just if you have any statistics about, like how often people are using alternative forms of input and output. Like our discussion in the chat is about how often people are using, speech as input. But if you have any, ideas about all these other forms of communication as well, that'd be interesting.
That's a great question. I do not have it in my top of my mind, but I know my, partners in customer success team, they deal with this analysis all the time. So I can find those numbers and share in the discussion chat after this session. And from my conversations with the customer, I know that, for example, WhatsApp is very popular in Europe and Asia. And I come from India. And whenever I'm in India, I see that most of my interactions with businesses are now happening on WhatsApp. So that's my experience, that in India, at least, a lot of companies are sending order details, appointment reminders on WhatsApp. But I can get you a ballpark figure of numbers as well after this session. Okay, thanks, Pamela, for calling that out. So moving to pricing. So how much would it cost you if you were to build something like this, where you use WhatsApp? So because WhatsApp and Microsoft are two different companies, they have two different charging models as well. So from the WhatsApp side, if you are using conversations which are initiated by the customer, for example, in our case, I started the hello first. It wasn't a marketing message that came from the business on my app. So WhatsApp provides thousands free conversations per month for your business account for these type of conversations where the customer is initiating the conversation. And ACS charges 0.005 cent per message per inbound and per outbound message. The good news is that if you have, the Azure credits that you get when you sign up for Azure for the first time, those credits can be applied toward Azure Communication Services WhatsApp messaging charges. I've also linked a page which has all the details about WhatsApp pricing model and ACS model when it comes to WhatsApp. Okay. I do see a question by Tom. It would be nice to have ACS integration with Azure Bot Services, which can also talk to Telegram and many other channels. Thank you for that question. So we do have support for Azure Bot Services for our chat communication channel. So right now that is available. For the other channels, we do not have that integration yet. Okay, coming to my next demo. In this demo, we will use a phone call to talk to a RAG application, or I can say an AI bot. So this bot is basically helping Milan cake shop's customer to help them place order for a cake on the phone. So what I've done here is that I have fed the cake menu to this bot, so the bot knows what kind of flavors are available, what are the different sizes that are available, and then I've used ACS for powering the PSTN part of the communication. So this is something I will have to run locally. I don't have it deployed. So I'm connecting to my remote desktop, which got disconnected. Okay. Taking some time to react. Okay, here it is. I have a dev tunnel already created. That means my local servers is exposed to the internet, so it will be able to receive call notifications from ACS. So let's get this started. Now I'm picking up my phone.
Hi, welcome to Milan Cake Shop. Are you calling to place an order for a cake?
Yes, I want to place an order for a cake.
Hello, I'm here to assist you with placing an order for a cake. What type of cake would you like to order?
Do you have anything fruity?
Yes, we have a fruity option called Berry Bliss. It's a light and airy vanilla sponge cake layered with fresh berries and whipped cream. It comes in two sizes, 6-inch for $32 and 8 for $42.
8-inch of Berry Bliss sounds good to me.
Great choice. I'll note down your order for an 8-inch Berry Bliss cake.
All right, thank you. Bye. So yeah, that was a short conversation. I just wanted to show you that this application is able to read the data in a way where it is able to answer straightforward questions as well. Like I didn't ask the app that do you have anything in berries, but I asked it, do you have anything in fruit flavored? And it just went through the cake shop menu and found something which was fruity. So let's see, if you had to do something like that, what would you do? So we will start with the architecture diagram. The user makes a phone call. The ACS call automation service receives that phone call. Now, this call automation service is an event-based model where it triggers event based on certain preset things. For example, when an incoming call comes in, it will generate an event and let my application know that there's an incoming call. And when that event comes in, my application can decide what do they want to do. For example, in this case, I wanted to play a starting message like, hello, welcome to Milan Cake Shop. How can I help you? So the application would do that. And then it will start the process of listening to the customer and then saying the response from the LLM back to back, like creating that conversation loop. So how does that happen? So when the application receives an event, it is going to use that input and then use the knowledge base that is connected to our AI search, and then pass it to an LLM to get a response. Now, this conversation on the right side of producing a human-like response based on the cake shop menu is happening in text. So we need to convert the text into speech because PSTN calling is happening on speech. Now, ACS call automation has native integration with Azure AI Speech. What it means is that you don't have to worry about calling Azure AI Speech or any other speech services that can do text to speech or speech to text for you. Instead, ACS does that for you under the covers. So that happens, and then your application will basically tell ACS call automation service to play the response that the bot generated. For example, when it found about the Berry Bliss cake, that text will be sent to ACS call automation and it will convert it into speech and play it on the connected call, which was through PSTN. Now, keep in mind, this is something that you can do on VoIP as well. like the architecture will remain the same. Instead of PSTN leg, you'll have a VoIP leg. Now, again, I have followed the same model where I have given the steps that you would need to do if you want to connect the PSTN part to your already existing application, or you want to create a new application which does all the jazzy AI stuff, but the communication mode is PSTN. What would you do if you were to use ACS? So the first step is same, create an ACS resource, which I've already shown it to you. It has another part where you have to get a phone number. Now with ACS, you can either buy your phone numbers or you can port your existing phone number using direct routing, because some of the businesses usually have their phone numbers associated with them and they want their customers to continue using their phone numbers and they don't want to change the number. So that is possible as well through ACS direct routing. Now, step 2 is that you use ACS call automation in the code, and then you create the endpoint to receive the events that I was talking about. That events that get generated when there's an incoming call, an event gets generated when the user speaks something and stops speaking, basically recognizing the input of the user. When I said, yes, I want to order a cake, when I finish my sentence, that's a new event that gets generated, and call automation service will take that text and pass it to my application. And then you have to create an endpoint in the event grid, like we saw before, to receive these callbacks. And then you run your app, and that's it. So we will go and see the code repo as well. But here are the two main functions that we'll focus on. One is an API event endpoint, which is an endpoint that you create for receiving an incoming call. When you get the incoming call, then you register a callback URL. And the callback URL is something that you have to expose in your application as well. And in this method, you handle different kind of events that I was talking about. So let's go to the code repo. It's called Cake Shop Phone Order. Again, this also has a full README, which will have instructions on how to deploy it locally, how to test locally, and how to deploy on Azure if that is something you'd like to do. So again, for this one, I've used minimal API, so there are like really less number of classes here. Actually, the main one is just program.cs. I do have helper.cs as well, which is a class that has my prompt. And this is a very descriptive prompt. Here I've given an example interaction as well. But prompt is something that is not the focus of the session. So I will move ahead. There are a lot of resources available online on how to finesse your prompt. So let's look at program.cs. This is our main class. And here, like I said in my slides, that there are two main endpoints that you'll expose. One is API event for receiving the incoming call. And here you will check the event type. If it's an incoming call, you will set certain options. For example, the main one is callback URI. Where do I call if I have events for this particular call that got connected? So you basically give the callback URI endpoint for your own application, which you have in the same class. And then there are some options that you have to set. Now, options are needed when you are doing speech to text, text to speech. If it was a human-to-human conversation, you won't need that. Here, you basically pass the cognitive services endpoint. This is where the connection happens under the covers. You just provide your resource that you have created for Azure AI services. For the speech to text, text to speech, you just pass that endpoint, and ACS takes care of the rest. And this is the second method. Here we will handle different sort of events. There are two main events when we talk about call automation. One is play and one is recognize complete. One is, sorry, not play, call connected, and one is recognize complete. Call connected is when the media gets established. The first message can go out then. And recognize complete is when the service recognizes that the user input has been received. And this is where you'll write code for your AI logic, because you've received the user input. Now, what do you want to do with it? I asked the LLM, do you have anything fruity? So you got that input here. What do you do with it? You create a chat history like we were doing in the WhatsApp demo, and then you call your chat completion API. Here I'm using Azure OpenAI again, GPT-35 Turbo, but you can use any other model that you would like. And then because it's voice, I want to use the streaming API. And when you use streaming API, you have to write some code to make sure that you are forming the sentence correctly. You are reading the word as it comes out, and then you're massaging it to remove some non-needed characters. But it's very simple to understand. You'll understand when you'll go through it, you'll understand what I'm trying to do. And then you call say and recognize async. Say and recognize async method will basically take the output that the AI LLM model generated for you, and then you will ask ACS to play that, and then wait for user input. That's why I'm calling this say and recognize. Play my message and recognize the user input. So that keeps going on till the conversation continues. So that's about it. It's not even 250 lines of code. It's like 212 or 230 line of codes for the PSTN calling. So I think that's
Milan, I had a couple questions.
Yes.
And this is a really cool demo. One thing we noticed was, a little bit of latency between, you asking and getting a response. And, we were debating what's the latency coming from, what ways could you, reduce that latency or even reduce the perceived latency. And I was also just trying to figure out whether you're streaming the response back, or are you getting the whole stream and then saying it?
So I am streaming the response back, but I'm waiting for a sentence to be formed.
Oh,
because
okay.
if I get just one word by word, and if the API starts speaking it, it won't feel natural. It'll be, yes, we have berry bliss cake. So that's the part that I'm doing there. I'm trying to form a sentence so that it feels more natural. The latency part, we do have a blog post that I can link where we're talking about how do we reduce latency when you deploy something like this in production. For my demo, it's very simple. I haven't added all those optimizations, but again, that's something I can share as well. But there would be some sort of latency unless there is a voice endpoint that gets exposed in an LLM where we can directly stream the voice input and directly get the voice output, because there's this PSTN call lag, but there's also the speech to text and text to speech. So two things are happening because there is some sort of latency. Even with optimizations, I think there would be a second or something that you'll have to wait. But if there was like an endpoint where you can stream voice directly, that would be like really real time.
Well, we were debating whether you could stall and say something like have the voice say, looking through our menu.
Yeah.
Whether you can like kind of do that while getting the response in parallel concurrently.
Yeah, that's a good idea. Yeah, we can think about that. Searching through my menu.
Really fun. So yeah, we're just brainstorming in the chat here. It's a really cool demo, and we all want cake now as well.
That was the plan, to make you all hungry. Okay. All right. Oh, what was I going to show? Yes, I was going to go back to the Azure portal to make sure that I also show you the other things that you need to do on the portal. We did cover the code part. Yes. So we come back to our communication resource. And before being able to code all that, you will have to have a phone number. And this is where in the phone numbers blade is where you buy a phone number. Now, this is something that you cannot use your Azure credits for because of telco restrictions. But as you can see, the cost of using a phone number is pretty minimal. And if you already have a phone number, like I mentioned, you can use that. And for PSTN call, you need to set the phone number, and then you need to set the event grid here. This is something that I have set up for my cake shop calls. And I have my local dev tunnel exposed and the API event endpoint. Remember, I showed you the API event endpoint for receiving incoming calls. That's what I'm using here. So when you are creating an event, you will have to select event type as incoming call here. And you're set. So that's about it from the code part for this demo. Now let's talk about pricing. So we did cover the phone number acquiring cost. Oh, but I forgot to mention a cool thing. So if you're using a phone number just for calling, ACS does have trial numbers now. So you can use free numbers for 30 days, I guess. I think for 1 month, yes. So if you're trying to build a hack project, you can use our trial phone numbers if you're using that phone number only for calling, because trial phone numbers do not support SMS or WhatsApp messaging. It just supports calling, both VoIP and PSTN. So if you're not using trial numbers, what would it cost? So there are two participants in a call, in a one-on-one call. One is the bot, which is basically an app participant, and one is a PSTN caller, which is me on the other end of the line. So the pricing is for both participants. For the person who is on the call and is using the person who is on the call, the cost is based on the country of the number. I was using a US number. So for my call, it'll be 0013 cent per minute. And for the app participant, which was the bot, it'll be 004 cent per minute. So I've also placed an example of, how would you calculate cost if the call had to last for 10 minutes. So you can take a look at that later. Now, with that, I am towards the end of my 2 live demos. And here are a bunch of resources. The first 2 are the code repos for the 2 samples that I covered. I'll skip mechanic sample for a bit. I'm going to come back to it. The last 2 are if you want to explore more ACS and AI samples, and if you want to try some of our quick starts for other channels or the channels that I showed to you. I've kept mechanic sample here because it's a very interesting one. I thought that if I have time, I would like to show that to you. I don't have that deployed right now, but I think it's just worth skimming through the README of that app. Now, so far, what I've showed you is that you take your AI application and you add a new channel to it, like you have WhatsApp, or you have SMS, or you have chat, or you have PSTN calling. But I've also have a sample where you use multiple channels together and you make sure the context passes from one channel to another. I wish I had time to deploy this before this session, but I didn't. So I will just go through the pictures that are available in the README of this sample to give you an idea of the workflow. And if you're interested to build like a multi-channel application where the channels are connected with each other and the context is flowing through those channels, I encourage you to check out this repo. Again, this also has full instructions on how to deploy this. In fact, it has biceps file. So you won't have to do a lot of work to set up the resources. The bicep files will do it for you. There's some manual steps and they are listed here, but you can also deploy and work on your local if you want. So let me go through the app flow. Okay, I think this is a good zoom factor. So the sample here was built for a fictitious company called Contoso Solar, Contoso Solar, and they have a Contoso Solar website, and they have a customer support bot which helps customers figure out what kind of solar panels should they buy. So the workflow starts from a chat bot. Again, we use RAG here because the bot needs to know what inventory they have, what kind of solar panels are available, what are the tax implications. All that stuff is fed into Azure AI Search, and the bot uses it. So the conversation starts from a chat conversation, and then the same application can convert this conversation into a PSTN call where the bot is talking to you, and it has the context of the talk that you had with the bot on the chat. And so here you can see that the customer has to give their number, and once they give the number, the bot will call on their phone. So once the call happens, the conversation conversation happens over PSTN with the bot. And during that conversation, you can also escalate to a human. You can say that I want to talk to a human. Can you start a call with an agent? And this application has code to do that as well. In that case, the call gets transferred to an agent. Now the customer who was speaking to the bot on the chat, was speaking on the bot on the call, is now speaking to an agent on a phone call. Now, this agent can also do video call with the customer, because, when you're buying solar panels, you can have questions like, hey, can you show me the neighborhood? I want to see how tall are the trees around your house, because that will help me decide what kind of changes you will need for your roof. So the agent can do a video call. And we also have co-pilot concept in this app, in this sample, where the agent is able to see the full chat history of the conversation that happened between the bot and the user. And then it also has some functions that it can do for the agent, like summarize the conversation, create actions, and create a summary which can be then sent as an email from the application. So it's a nuanced sample. It uses a lot of concepts of ACS and AI, but it doesn't have the nuances of supporting multiple people talking to the application. It was built just like to show the proof of concept. So it's just like one person talking to the chatbot, and that's why we don't have any storage in this sample. But it's an exciting one. I do encourage you to check that out. It's called Mechanics Sample because it was premiered on Microsoft Mechanics YouTube channel. If you're not aware, Microsoft Mechanics is a very popular show where they cover different products of Microsoft and different concepts, and dive deeper into it and show some really cool demos. So do check that out. With that, I'm done with my session. I hope you enjoyed it. And if there are any questions that I couldn't get to in the chat, please take them to the discussion thread, and I will be active there. So with that, thank you for joining again.
Hey everyone, hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.
Thanks everyone for joining. Thank you, Milan and Pamela. To learn more about this series, watch past episodes, and register for future sessions, you can follow the link at the bottom of the screen, aka.ms/raghack/streams. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23512. We'll see you at the next one.